Our next rule is the product rule, and it allows us to differentiate functions times other functions. That's the formal definition where u and v are just different functions, but how I remember it is like this. Write down the first and diff the second, plus write down the second and diff the first. Again, it's just a way of saying it, and you do it as you say it. Makes it easier to do. So write down the first, diff the second, plus write down the second and diff the first. So what do we mean? Sure, I could expand this out. This one's not too difficult to expand out. Where the product rule is going to be really useful is when we look at more interesting functions like trig functions and exponentials. If you've got an exponential times a trig function, well, you can't expand that out. And so the product rule becomes very, very useful. But we'll use this because at the moment all we really know is about polynomials. So write down the first, diff the second, plus write down the second, diff the first. Here we go. Write down the first. Well, the first function is x to the power of 7, so I write it down. Diff the second. Well, the second function is x to the 9 minus 6. Differentiate that, I get 9x to the power of 8. Plus, write down the second. Well, the second function, x to the 9 minus 6, diff the first. Differentiate x to the power of 7, and I get 7x to the 6. There's my derivative. Now we tidy that up. Oh, we've got a couple of like terms, and we have our answer. Now the reality is, for something like that, it probably would have been quicker to expand the initial thing out and just differentiate that. Binomials, again, is it easier to expand it out first, then differentiate? Well, let's do it the other way. Let's see what happens. Write down the first, x minus 2. Diff the second, 2. Plus, write down the second, 2x minus 3. Diff the first, 1. You're still collecting alike terms, 4x minus 7. Was it quicker? I suppose my expansions that I ended up with are easier than the first one, but I mean, it's not like that was a hard expansion. Okay, let's try this one then. Now this time it's in the form, just differentiate this. So I'll go straight to equals the answer here. Write down the first, x to the 7 minus x cubed, diff the second, 6x, plus write down the second, 3x squared plus 7, diff the first, we end up with 7x to the 6 minus 3x squared. Now I'm going to have to expand all that out, collect like terms. I think in this case it definitely would have been quicker just to expand first of all, because if you look at my final answer, I still had to expand a binomial out anyway. So what time did I save on that one? Not a lot. 3x times x squared plus 4 to the power of 5. Well, it's certainly going to be quicker for this one because I do not want to expand out x squared plus 4 to the power of 5 and then multiply everything by 3x. That's just going to take too long. Write down the first, 3x. Diff the second. But the second is x squared plus 4 to the power of 5, so now I have to use our other rule that we've seen, chain rule, anarchy. So bring down the power, 5. Lower the power, 4. Diff the inside, 2x. The big mistake people make is to now forget to go plus the next bit, because it just feels like you've done so much. Oh, I've done everything, move on. No, we still have to go plus. Write down the second, x squared plus 4 to the power of 5, diff the first, 3. Okay, there's a bit of tidying up to be done here. Yeah, that's an answer. It works nicely. But if I want to factorise this to get it to one expression, I look for common factors. There's certainly a common factor of 3 there. There's also a common factor of x squared plus 4 to the power of. Well, when we factorise, we always pull out the lowest power. So it'll be x squared plus 4 to the power of 4 that we would pull out. So I've pulled out the x squared plus 4 to the power of 4. For some reason I've left the 3 in there, but anyway. That inside leaves me with 30x squared and 3 times x squared plus 4. 3 still in there, don't know why I haven't pulled it out. So inside becomes 33x squared plus 12. Finally I pulled the 3 out. Why didn't I do that at the start? I have no idea. Anyway, it's out. 3 outside x squared plus 4 to the power of 4 times 11x squared plus 4. Again, this one, it's certainly going to be useful because I can't expand out 2x plus 1 to the power of a half. Write down the first, 2x. Diff the second, but for the second I'm going to have to use chain rule, anarchy. Bring down the power, a half. Lower the power, minus a half. Diff the inside, 2. Plus, write down the second, 2x minus 1 to the power of a half. Diff the first, 2. Whew, let's tidy that up. What have I got? Half times 2 times 2x gives me 2x. Now, we have a common factor of 2. Hopefully I remember to take that out this time. But we also have 2x minus 1 to the power. One's negative a half, one's positive a half. Doesn't matter, it's still the same rule. You pull out the lowest number. The lowest number is negative a half. So I pull out 2x minus 1 to the negative half, leaves me with 2x minus 1 to the power of 1, because remember, factorising is dividing. So I would subtract the powers, and a half minus a half is 1. There it is as an answer. Well, that's what a mere mortal would write as an answer. But us super mathematicians go, no, power minus a half, we won't have that. 2 outside of 3x minus 1 over the square root of 2x minus 1. Okay, so that is our product rule. 9H we'll add.